Hello everyone. Today we are going to discuss the most difficult subject what students generally feel. It is the quantum physics. So before going to this subject, actually we should know the brief history of the quantum mechanics. If we know the problems actually why quantum mechanics come into picture, what is the relevance of the quantum mechanics, whether do you really need quantum mechanics. If you know the history, then only we will clear about the fundamental of the quantum mechanics or quantum physics. So today we will discuss the brief history of quantum mechanics, what is the importance of the quantum mechanics and where it is coming from, why we need quantum mechanics. Okay, so please come to the history. First, all we are about the classical mechanics that we have already studied in this our BSc physics honors classes, and also in the past classes also people study the classical mechanics. The classical mechanics, it was started by Isaac Newton at the end of 17th century. When I was talking about 17th century, that means it is in between the 1600 to 1700 years. During this time duration, classical mechanics was developed by Sir Isaac Newton, and further it was modified by the Lagrangian and Hamiltonian. As we studied in the classical mechanics, there are different theories. The Hamiltonian, the total energy equation of motions in the terms of mathematics, and the Lagrangians and Hamiltonian, they have developed the classical mechanics which was introduced by the Isaac Newton. But the most important and the interesting fact is the classical mechanics was designed in such a way it was able to explain all the physical phenomena those are happening around us. Like it perfectly explained the motion of the particles, rigid, and the motion of the not only the particles, also the rigid bodies motions, the motion of the fluids, the projectile motions, the motion of the celestial object like the astrophysics, when we are talking about the motion of the planets, motion of the satellites and the asteroids. All these motions it also can easily explain by the existing classical mechanics. Also, not only these things, electromagnetism also it can be explained by this classical mechanics, thermodynamics, optics. So when all these physical phenomena were explained by the existing classical mechanics, then people thought there will be no fundamental development need in the physics, because what are the existing physics during that period, it was successfully explained all the physical phenomena those are happening around us. But at the end of 19th century, it was started during the 17th century classical mechanics, means after 200 years. At 19th century, at the end of the 19th century, that means it is towards 1890. At that time, many physicists believed that the conceptual physics has already reached at the dead end. That means no further development needed here in physics. No fundamental research is not needed here in physics. Then the physicists, they have to think about some applied things, but the fundamental research should be stopped because physics has already reached the dead end. At 1890, the physicists believed that we have already at saturation point. In the 20th century, many physical phenomena observed at that time which could not explain by the existing times tested most faithful classical mechanics. Means at 20th century, at the beginning of 20th century, the classical mechanics actually got a shock, because first time physicists failed to explain some physical phenomenon using the age-old classical mechanics. Then only a new physics came into existence to solve this type of problems which could not easily explained by the existing classical mechanics, and this is known as quantum mechanics. This is the history how and why quantum mechanics come into picture. So when quantum mechanics come into picture, there are many physicists too which has contributed a lot to groom the quantum mechanics. And now we can find in technology, quantum mechanics is the hot topic where lots of fundings are poured in quantum mechanics to do many big research. So at that time, the quantum mechanics was groomed by Planck, Einstein, de Broglie, Heisenberg, Bohr, and many other people, because when it was started, many physicists even they want to believe that quantum mechanics is a real thing. Is it real? Is it a true physics? Nobody at that time believed. Many other physicists, they won't believe quantum mechanics is such a new physics. But those physicists, they have taken this challenge and they tried to prove, yes, it is also a physics like other physics, and we can also achieve many things like in the electromagnetism, thermodynamics, optics. Now we can see many electrical appliances, those are using this basic concepts, okay. Then at that time when quantum mechanics born, then people don't believe, but many physicists, they take the challenge and they try to prove, yes, quantum mechanics is there, quantum physics is there. If you do lots of research, also it can help the mankind. And now we are seeing the quantum computation, the supercomputer, all the basic techniques are the quantum mechanics. And many thanks to these physicists, those have taken the challenge at the initial stage, and now we are taking the fruits of the quantum mechanics. The quantum idea was first conceived by the Max Planck while he was trying to solve some unsolved problems. Like some problems I explained here where the classical mechanics failed. One of the problem was the blackbody radiation's energy distribution curve. It was not explained by the classical mechanics. When Planck was trying to solve these problems, then they got the idea of the quantum. He explained, though in the classical mechanics we are considering the energy has a continuous values, but he suggested it is not a continuous values, it is a discrete values. Yeah, it can be considered as the combination of packets. It is not a continuous things, it is a combination of packet. If we try to understand those things, the discrete and the continuous, suppose you are going to purchase a sugar from a shopkeeper. Suppose you are going to purchase sugar from the shopkeeper. So there is two shopkeeper, one is shopkeeper 1 and one is shopkeeper 2. So this shopkeeper 1 has the packet of sugar. Suppose it is 25 kg sugar it has, and in the shopkeeper 2 it is a mall, shopping mall, where only you can find the packets. You don't find the big packet like 25 kg packet, it is only 250 gram. It is only 250 gram packets. So when you are trying to purchase the shopkeeper 1, if you want to purchase 100 gram, it will give you. If you want to purchase 200 gram, it will give you. If you need 250 gram also, shopkeeper 1 is ready to give you, because he has to give the sugar from each packet of 25 kg. He can open and he can give you any amount you need. That means what is the shopkeeper 1 is doing, he can give you any amount, any continuous amount. That means there will be no concept of packet. Any amount you need, you can get it. Similarly, in the continuous energy means if you want 1 joule, 1.5 joule, 2 joule, every energy is available for this classical mechanics shop. But when you are going to shopkeeper 2, it is a mall, there you won't find this packet. If you go there, you have only options, either you have to take 250 gram or 2 packet 500 gram or 750 gram or 1 kg gram. Whatever the sugar you will collect from this mall, a shopkeeper 2, it should be multiple of 250 gram, because the packet's minimum amount is 250 gram. Similarly, in quantum mechanics, Planck stated that whenever you are talking about the energy of the radiations, it should be calculated in terms of packet. And this small packet is nothing but the quanta, and every energy is the multiple of quanta. This is the concept of quanta and where the quantum mechanics start.